Hello friends, this is Priyanka. Today we are going to solve a problem on frequency response analysis. In this video, we have to draw the frequency response for a given system g of s is equal to 1 divided by s square plus 2s plus 4. So how to plot the frequency response? For that we have to plot the magnitude response as well as phase response. Let us first convert this given system into frequency domain. So how to convert this? That is, we have to take instead of s, that is j omega. So we can say that sinusoidal transfer function g of j omega is equal to, that is, in this given transfer function we have to replace this s with j omega. So I will write here 1 divided by s square. So instead of s square I will write j square omega square. Now what is the value of j? So j is equal to under root of minus 1 and therefore j square is equal to minus 1. So I will write here j square omega square, that is minus 1 into omega square, that is minus omega square plus 2s, that is 2j omega plus 4. Now this is the combination of real number and imaginary number. So we will separate the real number and we will separate the imaginary number. So how we can write here, which is equal to 1 divided by 4 minus omega square bracket complete plus 2j omega. So we have to rewrite this equation. So here is the first number, that is real number, and here is the imaginary number. So I will underline this. This is real and this is imaginary. Now how to plot the magnitude response? So for that we have to take the modulus of gj omega. Now what is the meaning of modulus of gj omega? That is, we have to cancel the negative signs. So when we take the modulus, then the negative sign is getting cancelled. Now if I take modulus for this gj omega, then we have to also take the modulus for this right hand side value. So we have to take this j. So j is equal to under root of minus 1. Then if I take square on both sides, then j square is equal to minus 1, and because of modulus this minus 1 is getting cancelled and getting converted into plus 1. So for that I have to take this denominator in terms of square, because we have to take instead of j, it is required to take j square. So how we can convert this? I will take square root and square simultaneously. That is, the meaning will remain same. So if I take square root as well as square for both the numbers, then what is happening? Here it will become 4j square omega square. But value of j square is minus 1. But because of this modulus, this minus 1 will be converted into plus 1. So I will write this, that is 1 divided by under root of. So we have to take under root of. So if we take the square root, then these two numbers I have to take the square, that is 4 minus omega square bracket square plus 2j omega bracket square, that is 4j square omega square. Now for this j square the value is minus 1, but because of modulus it will become plus 1, so only 4 omega square is there. So this is the magnitude of response that is getting completed. Now we will move for the next step, that is, we have to calculate the phase response, that is angle of gj omega. So we have to take the angle of gj omega. So how to find out this angle? So here is one basic formula, that is j omega plus a divided by j omega plus b is equal to tan inverse of omega by a minus tan inverse of omega by b. Now if we observe here, j omega plus b is in the denominator, so we have to take minus tan inverse of omega by b. Now we will understand why here the angle is tan inverse. Now if I take these are the two numbers, that is, this is the real number and this is the imaginary number. So I will take here the S plane, that is, this is the real axis and this is the imaginary axis. Now here 4 minus omega square. So I will refer here this real number something where here, that is this positive line, that is positive numbers on real axis 1, 2, 3. So 4 minus omega square, and here 2j omega. So this is also having plus sign. So here this 2j omega, I will refer here this value. So how to plot this point? So point is, I will extend this vertical line and horizontal line, and this point of intersection is here. Now we have to find out the angle. So if I join this point with the origin, then here is the angle theta that we have to find out. Now what is this vertical distance? So vertical distance is 2j omega. And what is this horizontal distance? So horizontal distance is 4 minus omega square. So these are the two values, and this is the right angle triangle. So we can say that tan of theta is equal to 2j omega divided by 4 minus omega square. So theta is equal to tan inverse of this value. So this value, that means we have to take the omega divided by b. So we can say that here in terms of j value, that is 2j omega, we have to take only 2 omega divided by b, that is constant, that is 4 minus omega square. So how we can take, because this value is in the denominator in terms of j, so I will write here minus tan inverse of omega. So we should not take here as a j, so we will take only 2 omega divided by 4 minus omega square. B means constant value or real value, that is 4 minus omega square. So this is the formula that we have to take. Now to plot the magnitude response and phase response, we have to take the value of omega that will vary from 0 to infinity. So when we put the value of omega is 0 in this formula, then what is the answer for this modulus of gj omega? So we have to plot here the numbers. Now in the same way, for the phase response also, we have to take the value of omega that will vary from 0 to infinity. So when we take the omega, that will take from 0, 1, 2, 10, etc. up to infinity. So if we put here the value of omega, then what is the answer for this angle of gj omega? So we have to plot here. Now if we observe this graph on this vertical line or y-axis, we have to take modulus of gj omega, and on this horizontal line we have to take the value of omega. This is known as magnitude response. Now in phase response, we have to take angle of gj omega on this vertical line, and horizontal line we have to take the value of omega. Now we will first make the table for the calculation, that is, we have to calculate all the values with the help of calculator by using these two formulas, and we will plot the graph. Now here I have made the table. Now we will plot the values. So for the omega, that is 0, modulus of gj omega is 0.25. So here is 0.2. So I will select point somewhere here. And angle is 0 degree. So for this 0 omega, angle is 0 degree. Then when omega is equal to 1, then it is modulus is 0.27. So for this 0.27, I will plot here. After that 0.27, and angle is minus 33. So minus 33 angle, that is in between this 0, here is minus 20 and here is minus 40. So somewhere here we have to plot one point. Then when omega is equal to 2, it is 0.25. So I will take here, that is 0.25, again here is same. And angle is minus 90. So minus 90 is in between 80 and this minus 120. So I have to take here. Here is the point. Then again when omega is equal to 5, then 0.04. So 0.04, that is it is below 0.2. Here is 0.1 So I will take here 0.1 and 0.04, that is somewhere here. So when omega is equal to phi, I will plot here 1 point. Then here angle is minus 154. So minus 154, that is here the angle minus 120 minus 160, that is here is minus 140. So here 154. So I will plot here the point minus 154. So when omega is equal to 10, value is 0.01. So 0.01 is nearly equal to this 0. So I will plot here 1 point. And angle is minus 160. So after angle minus 160, I have to take here minus 168. Now if we observe the next values, that is after 10, the value will vary from 0.002 up to 0. That is, difference is so small, in between 20 to infinity. Now if we refer the angle, then for 20, when omega is equal to 20, angle is minus 174, and when it is infinity, it is minus 180. So difference is very small. So after 10, we can show the graph as a straight line because of small difference. So I will join the points. So here also I will join the point. So this is the graph, that is magnitude response and phase response for the answer of frequency response plot.